Kuwait is one of the fastest growing economic regions in the world, and the population is also growing steadily, by up to about 3% per year. The mission of the Kuwaiti government is to provide an advanced infrastructure and sustainable living areas for the growing number of residents. Following an international invitation to tender, together with WTE and IFA, it intends to implement one of the world's largest wastewater projects for optimizing wastewater treatment systems as well as for wastewater transport, according to the highest environmental standards. The contract agreement further develops the classic PPP model into an advanced future-oriented feature adapted to local conditions. It especially implements the following milestones: 25 years of operation of the new wastewater treatment plant, participation of Kuwaiti public entities as equity shareholders, participation of Kuwaiti citizens via stock market shares, implementation of turnkey works for pipes, reservoirs and pumping stations into the project in order to achieve a maximum of cost transparency, construction time optimization, and integration of interacting assets such as wastewater transport and wastewater treatment systems.
The products resulting of the cleaning process are much more attractive and sustainable than people might assume. The Kuwaiti citizens are invited to participate as shareholders with guaranteed and attractive dividend. This will surely improve the acceptance of the public for wastewater-related issues.
One of the key elements to be performed by the project company is the construction of the network with a length of about 450 kilometers. Another one is the pumping stations. The existing Egeila pumping station is located in the north of the project area. Its hydraulic capacity has to be increased from its current 2.8 cubic meters per second to 8.3 cubic meters per second, with a delivery head of about 135-meter water column. From Egeila, 3 parallel wastewater transmission mains lead to the plant in the south. They will be placed in a 45-kilometer-long corridor, mainly parallel to Highway 40. Al-Heyman City Pumping Station is located approximately 6 kilometers northwest of the plant. After refurbishment, the existing pumping station will transfer the wastewater to the plant. In the southwest of the project area, the new Sabah Al Ahmed city will have its own pumping station with a hydraulic capacity of 2.2 cubic meters per second. 2 parallel transmission mains will transfer the wastewater over about 33 kilometers to the plant. The network and the pumping stations will be operated for the first 3 years by WTE.
Looking at the network, we will use ductile iron pipes with special lining and coating systems. They are well known as a high-end product with a long life cycle. Definitely the biggest challenge in this extraordinary project is the extremely tight implementation period. The project company shall implement the core elements within 30 months from date of signature and shall complete the remainder of the works within 18 months thereafter.
The heart of the project is the wastewater treatment plant, with an initial hydraulic capacity of 500,000 cubic meters per day and 1.7 million people equivalent. The state-of-the-art design accommodates the possibility for further expansion to 700,000 cubic meters per day at a future date. The plant will treat the wastewater to the specified treated sewage effluent standards, which are more stringent than the local requirements. All the wastewater from the pumping stations enters the plant in the terminal inlet chamber. From this chamber, the wastewater will be distributed to the inlet screening and the aerated grit chambers to remove coarse materials and sand as pre-treatment. After passing a pre-aeration zone, which can also be used as a flocculation zone, the wastewater will be directed to the primary sedimentation. The objective of primary sedimentation is to remove readily settleable solids and floating material, and thus reduce the suspended solid content. In secondary treatment, biological and chemical processes are used to remove most of the organic matter and nutrients like nitrogen and phosphorus. The processes mainly take place in the aeration tanks. Dissolved oxygen demand will be provided by highly efficient turbo compressors. The overflow from the aeration tanks will be sent to the secondary sedimentation tanks, where the suspended biological floc settles out while the treated water moves into the tertiary treatment. Tertiary treatment is the last step of the entire wastewater treatment process. After a filtration stage to reduce the solids, the water will pass an ultraviolet disinfection, followed by gaseous chlorine as final disinfection stage. The combination of the aforementioned process steps guarantees an effective disinfection with an excellent residual effect. After tertiary treatment, the wastewater has been transformed to a high-grade and valuable resource, which will be partly used as water for irrigation purposes.
WTE, with its highly specialist employees, has implemented much more than 100 projects in the water and wastewater domain worldwide. All of them designed to ensure best available wastewater effluent standards. But what about sludge? Today, everyone is focused on the best technologies for an effective treatment, environmental friendly utilization of sludge.
Each wastewater treatment produces sludge. By way of a two-step thermophilic, mesophilic anaerobic digestion, the sludge is stabilized. At the same time, biogas is produced. The biogas will then be utilized in highly efficient combined heating and power stations to meet most of the electrical and thermal energy needs for plant operation. After digestion, the remaining sludge is dewatered and further treated in a state-of-the-art and fully automatic lane composting. The final product, in Class A quality, can be used as fertilizer in agriculture. To secure the supply of electrical energy to the plant, an electrical substation and overhead in-feed line has to be constructed. The 300 kilovolt substation is designed with an additional capacity for the future supply of the Ministry of Electricity and Water clients like KOC and others. Treated sewage effluent is an asset. From the plant, it will be distributed over the whole area. The industry and agriculture will benefit from this water. To secure this, a network with a total length of about 250 kilometers, including 39 strategic and secondary reservoirs with capacities of up to 160,000 cubic meters, will be implemented. Adjacent to the main reservoir, with a volume of 160,000 cubic meters, a data monitoring center will be implemented. The center will provide the functions, central administration and control, and laboratory in one location. The sea outlet shall be used to dispose of excess treated effluent to the sea. From the northeastern corner of the plant area, the pipe leads into a straight line to the sea, where it will be extended for another 2 kilometers. The construction method for this offshore part will be micro-tunneling.
The Al-Heyman wastewater project will serve more than 1.7 million citizens in the south of Kuwait and transform wastewater into green energy, compost as fertilizer, and water for industrial and agricultural use. This project will lead to a further improvement of the overall state of infrastructure in Kuwait's water and wastewater sector.
By combining national and international expertise, the Al-Heyman wastewater project will emerge as a beacon project in the Middle East. It is characterized by its special contractual structure, complex technical concepts, innovations, the highest degree of security and sustainability. This challenging project will be realized in close partnership and cooperation between WTE, IFA, and the Kuwaiti Ministry of Public Works.